Today we are taking notes on writing a complex number that's in polar form, and we're going to convert it to rectangular form. So remember last time we did a complex number in rectangular form and we converted it to polar form, right? Now we're going to go polar form to rectangular form. All right, so example 1, we are going to write z equals 2, open parentheses, cosine of 60 degrees plus I times the sine at 60 degrees in rectangular form which is z equals a plus bi. All right. So we can see that the modulus is what? 2. And the argument, which is theta, is what? 60 degrees. Okay. So we're going to use the exact values when possible. For cosine and sine to write the number in rectangular form. So like, yes, we can find the cosine of 60 degrees and the sine of 60 degrees in our calculator, but it's not going to give us, like if it has a radical in it, it's only going to give us decimal form, right? So if it's an angle that we know that we can find in the unit circle and we can find the exact value of, then you want to put in the exact value. If it's something that's not found in the unit circle, then the decimal form is fine, okay? But if it is on the unit circle, put the exact value. So like for 60 degrees, that's in the unit circle, right? What quadrant is 60 degrees in? Quadrant 1. So just as a reminder, if we make a right triangle, in the unit circle, we know the leg across from the 30-degree angle is what? 1/2. And the leg across from the 60-degree angle is square root of 3 over 2. So the cosine is 1/2, the sine is square root of 3 over 2. Now, for cosine of 60, or cosine of 60, 0.5, 1/2, same thing. But for the cosine of, or for the sine of 60, it would say 0.866 approximately. It wouldn't say square root of 3/2. So this would be the rounded value. Square root of 3/2 is the exact value. So if we can find the exact value, that's what we want to use. Okay. So the polar form was z equals 2 times the cosine at 60 degrees plus I times the sine at 60 degrees. So we know what the cosine of 60 degrees is and what the sine of 60 degrees is. So we're going to substitute those values in. So c equals 2 times the cosine of 60 degrees was 1/2 plus the sine of 60 degrees was square root of 3/2, but we got to put that I with it. So square root of 3/2, and either put the I to the left of the radical or to the right of the fraction. Okay, but we know in rectangular form, there's no parentheses in rectangular form, right? So we can distribute that 2. And what is 2 times 1/2? 1 plus 2 times the square root of 3/2. Aren't those 2's going to cancel and leave you with square root of 3i, but we wouldn't write it like that. We would say I square root of 3. You want to put the I to the left of the radical to avoid any confusion. You don't want it to look like it's under the radical. And that's our answer. Just like that. Is that a little blurry? A little blurry. Y'all good with that? Bless you. All right, y'all ready for the next one? This is difficult stuff, is it not? Yeah, so difficult. Example 2. We're going to write z equals 4, open parentheses, cosine 30 degrees plus I times the sine at 30 degrees in rectangular form. All right, so what is my modulus? 4. What is my argument? Do we know the exact sine and cosine for 30 degrees? It's in the unit circle, right? We don't need to use our calculator. 30 degrees is in quadrant 1. We know the leg across from the 30-degree angle is 1/2. The leg across from the 60-degree angle is square root of 3/2. So the cosine is square root of 3/2, and the sine is 1/2. Oops, easy. So we're going to say, I'm going to rewrite it as it was given to me. So z equals 4 times the cosine at 30 degrees was square root of 3/2, plus the sine at 30 degrees is 1/2. So I'm going to put 1/2 I, because it's I times the sine at 30 degrees, right? Then I'm going to distribute that 4. So z equals, that would be 4 square root 3/2 plus 4/2I, because the 4 would be in the numerator, right? And then of course I can see that I can reduce that. So 4 and the 2, neither are under the radical. So I can reduce that to 2 square root of 3 plus 4 divided by 2 is 2I. Back to rectangular form. Coolio. Any questions? All right, let's do one that is has radians. Right. Z equals 8 times, open parentheses, cosine of 7 pi over 4 plus I times the sine at 7 pi over 4. So 7 pi over 4. If I want to know the degrees, what am I plugging in for pi? 3.14 or 180? 180 degrees. So 7 times 180 is 1,260. Divide that by 4, and we get 315 degrees. Is that an angle that we can find on a unit circle? Yeah. Okay, so let's check it out. What quadrant would that be in? Quadrant 4, because 90, 180, 270. How far past 45? Okay. So this is 315 degrees. So what's the measure of my reference angle? 45 degrees. And so these are both 45 degrees. And a 45, 45, 90, the two legs are going to be the same distance or the same length, which is what? Square root of 2/2. But we're in quadrant 4, so my sine, SIGN, might be different for cosine or sine. We have to think about it. So what is the cosine? Square root of 2/2. And what's the sine? Negative square root of 2/2. Very good. Okie dokie. Well, I'm going to rewrite the problem as it was given to me. So z equals 8 times the cosine was square root of 2/2 plus the sine is negative square root of 2/2. So I'm going to say minus I square root of 2/2. And then obviously I'm going to have to come clean this up. So you can reduce as you go, or I'm going to just rewrite it. 8 times square root of 2 over 2 is 8 square root of 2 over 2, and then I'll come back and reduce it. I know this, a positive times a negative is going to be a negative. So negative 8i square root of 2 over 2. And then on both of those, the 8 can divide by 2. Neither are under the radical. So that would be z equals 4 square root of 2 minus 4i square root of 2. Cleo, I'm gonna give you one more and then an assignment. So on the last one, well, I'll give it away. We are going to write z equals 20, open parentheses, times the cosine at 205 degrees, plus I times the sine at 205 degrees in rectangular form. All right, what quadrant would 205 degrees be in? The third quadrant. How far past 180 will I go? $25 degrees, right? Is that going to be an angle that's found in the unit circle? No. So this is not an angle that we know the exact sine and cosine. So we will use the calculator to estimate. All right, so we have z equals 20 times cosine 205 degrees plus I times the sine at 205 degrees. So z equals 20 times, calculator, cosine of 205, 205, cosine is negative. I'm going to round to the nearest thousandths. So negative 0.906. Plus sine of 205, 205 sine is negative 0.423i. And then we'll distribute. So you know what? I'm going to put cosine of 205 in my calculator. So I really won't be rounding to the end, times 20. And that gives me negative 18.126. And then I'm going to do 205 sine times 20. And I get negative 8.452. Don't forget your I. No I, it's not right. And there you have it. As hard as it gets. Julia, y'all ready to do some homework, classwork, whatever works? All right, you can get these done pretty quick, and it is only 10:44.
Hi. I have a treasure trove. No, you need. Better call it.
Oh.
So you have to come and take one.
A treasure trove. I would love it.
Brand new.
Yeah, fine with me.